with us Dr. P. Vinod, and he is going to present his talk on the topic machine learning, how models can machine unlearning, how models can forget by design. So, as a brief bio, I would like to read about him is Dr. Vinod. Dr. P. Vinod is presently a Marie Curie Fellow at the University of Padua and a professor in the Department of Computer Application at Cochin University of Science and Technology, Kerala. He was a postdoctoral researcher at the Department of Mathematics, University of Padua, Italy, with a project named Tagit Smart. He was also a postdoctoral researcher at Malviya National Institute of Technology, Jaipur, Rajasthan, under the ISEA project on mobile security. He holds his PhD in computer engineering from Malviya National Institute of Technology, Jaipur, in 2020. He was awarded the Seal of Excellence for a Marie Klodowska-Curie Individual Fellowship by the European Commission. He has numerous research articles published in peer-reviewed journals and international conferences. He is an active reviewer of a number of security journals such as IEEE Transactions on Information Forensics, IEEE Communication Surveys and Tutorials, and Elsevier Computer Communications. He has also served program committee members in various international conferences, and his area of interest are malware analysis, adversarial machine learning, cyber threat intelligence, federated learning, and natural language processing. So now over to you, sir.
Thanks for the kind introduction. I hope I am audible. Can you hear me?
Yes, sir. Please go ahead.
I hope my slides are visible.
Yes, sir.
Just a request, like I see some audiences unmuted, so it is like echoing back to me. So I would request everybody to please mute so that I can start my lecture. So, thank you for the kind introduction and the opportunity that is given to me. Presently, as introduced, I'm speaking from Italy. So, it's early morning here and an afternoon India. So, I'm a Curie Fellow at University of Padua, Italy, and where I'm executing the European project called as Optima, which is Organization Specific Threat Intelligence Mining and Sharing, where our primary objective is effectively share the threat intel data across organizations in privacy preserving manner using concepts of federated learning, then differential privacy, also blockchain. So I would be speaking today on machine unlearning. This is a domain which I'm investigating from past 1.5 years. And the title of the talk is Machine Unlearning, How Models Can Forget by Design. So why is this domain uh, important today is can be motivated by the world map, where you can see that different parts of the countries are actually having different privacy laws. So for example, something which is known to most of us is the European GDPR law, and maybe like the CCPA in the consumer. I kindly request you to please mute. Somebody is unmuted, please. So So, why privacy laws are important? Privacy laws are important because of all these facts. For example, right to access, which means the user's personal data is. I'm getting the voice. Please mute. It's difficult for me to speak.
Participants, please mute your mics. It's creating disturbances.
ट्रेन यार जो है कोई ट्रेन
Uh,
नहीं है हमारे पास पैसे ही
Indra
नहीं
Kumar
है
Singh, please, sir, mute your mic.
साहिब नहीं आएगा तो बैठे तो
Yeah.
Yes, sir. Please continue, sir.
Can you hear me now? So then we have right to access portability of data, which means that the user has got full freedom of telling different providers like who can use their data. Then right to be informed, which means that the individual must be informed before the data is gathered. Likewise, the most important thing is right to be forgotten, which means that if some business organization is collecting my data and at later point of time I feel that my data is sensitive, then I have full freedom to ask the organizations to basically delete my data. So which is called as the right to be forgotten, and which is the primary emphasis of GDPR. So why machine unlearning? So primarily machine unlearning is important because of the privacy regulations in different parts of the country. So one of the very famous one is the European GDPR, which talks about the right to be forgotten. So every user has got a freedom where they can say or they can ask a company or an organization who is using their data for building machine learning models to forget the data. And the second one is the California Consumer Protection Act. So in overall, what is required is that there should be transparency in data handling. So I would like to quote from Article 17 of European GDPR, which says that the data subject, which means we who are providing the data, shall have the right to obtain from the controller the erasure of personal data. So the controller is like some company we can imagine who is trying to acquire our data in order to develop a machine learning model. Let's say for a recommendation system or for some other task. Without undue delay, and the controller shall have the obligation to erase personal data without delay. So, which means that if we want uh, an organization to forget our data, so once a user basically says that the data has to be removed, it has to be removed immediately. So, this is as per GDPR Article 17. So, what is machine unlearning? So imagine that when we want to train a machine learning or a deep learning model, what we try to do is first of all collect large amount of data. So this data uh, can be basically separated into two part. One part which the machine learning model should remember, which we call it as a retain set. And the second part that we want to remove, which is because of consisting of like sensitive information, which is called as the forget set, which is shown here in this diagram, uh, like through an object labeled as removed data. So we have the original data. Basically, what we try to do is we segregate these two data into two portion. One is the remaining data or the retained set, and the second portion is called as the removed, the one that we want to remove, which is the forget set, because it contains the sensitive data. So in the classical training process, what we try to do is we will present the training set to a classification algorithm, and this model, this algorithm will try to learn the intrinsic patterns present in the data. Now, let us imagine that some users are requesting for the deletion of sensitive data, which is shown by this. Then, basically, what we have to do is from the original model that is deployed by an organization, okay, who is creating this machine learning model, they should remove this particular data somehow, and then they should try to develop a model which does not have the contribution corresponding to this removed set or forget set, and such a model is called as an unlearned model. Now what we want effectively is that the performance of this unlearned model should be equivalent to a model which is shown on the left hand side, which is called as a retrained model. And by the definition, what is a retrained model? It's a model which has been trained from scratch without the removed data. So that means it is only trained from the data set, which is like the retain set. So that means essentially it will be trained with the data set which is not consisting of any private information corresponding to the user. So at the end, what we want effectively is the performance of the unlearned model that one organization is trying to develop, or what we want to achieve should have identical accuracy or performance than the retrained model. So, so as I said, this unlearned model will not have any trace of the removed data set or the sensitive data set. So it will not memorize this. So what are the different categories in which the unlearning algorithms are divided? So we have primarily two categories. So one of the category is called as an exact unlearning. So in exact unlearning, what the model developer tries to do is they will try to physically remove the data points corresponding to a specific user who has requested the sample to be deleted. So it is a physical removal. On the contrary, there are a cluster of algorithms called as approximate unlearning, where an unlearned model is created by doing some changes in the parameter space of the model. So either trying to uh, modify the weights of the model corresponding to the sensitive data points, or modifying the gradients. So in an essence, what would we would like to have from all these two methods is that the unlearned model should completely remove the influence of sensitive data. So why this unlearning cannot be done from just removing the sensitive data from the complete data set and retraining from scratch? The whole idea is the retraining from scratch is an expensive process. Think about a large language model which is trained using a huge volume of data that is available in the cyberspace. And if, let's say, it is getting if multiple users are sending a request to an organization in order to unlearn the data, so which means that it will require periodic retraining, which is computationally expensive, and it is also not a sustainable solution because it adds more carbon footprint. So we will discuss today two techniques. So one of the technique is called as an exact unlearning. So just to remind you, the exact unlearning techniques means that we would like to basically. Am I audible? Just to check. Can you hear me?
Yes, sir.
Okay. Thank you. So, in case of exact unlearning, our whole idea is to remove the data points, okay, in order to negate the effect of those data points from the model. So, one of the approach is called as CISA, which was actually proposed by a group from Nicholas Peppernotte in IEEE SMP, which is the top security conference rated A star. So this technique is called as CISA, and the expansion is the first S stands for sharding, isolation, slice, and aggregation. So this technique is effective compared to the classical retraining the model from scratch. So let us try to understand what are the four components of this technique. So sharding means that we take the complete data set and we divide it into multiple blocks or subset, where each block is called as a shard. So let's say we have 10 subsets, okay? Each subset containing 100 samples. So every subset is called as shard. So now we will try to develop 10 different models. So essentially we are developing 10 sub-models, and each sub-model is subjected to the shard. So every sub-model is learning the attributes or characteristics of every shard. And one of the important point to remember is that there is no overlapping bit of the data points from between these shards. So for example, if you have shard 1 and shard 2, you will not find the same elements in both the shard. It is not possible. Then the second point is isolation, which means that each of the sub models will be trained in isolation with the shards or the subsets. So that means there is no interactions between these submodel. And how the training happens in the same conventional style of training a machine learning model, where the shards are further divided into smaller batches, which is called as slice. And when we train an machine learning or deep learning model, we will basically have a multiple iteration, and in every iteration we will present the batches. So we have the forward pass, then the error or a loss is calculated, and if the loss is higher, it is back propagated. So the same concept is applied. So batches within the shards are technically called by these authors as slices. And finally, when we have multiple submodels trained, then what we try to do is we aggregate the outputs from these submodels, and this aggregation can be performed using majority voting or averaging. So let us try to pictorially look at what we have basically discussed in the previous slide. Is we have a complete data set, and this data set is divided into number of blocks which are called as shards. So here we can see there are n shards, and you can see within each shard some number of disks, which is nothing but the batches or slice. And then we use multiple models, and each model is presented with the shard. So these multiple submodels are created, and finally aggregation is performed from the output of these submodels. So this is basically the entire concept of sharding, isolation, slicing, and aggregation. Now let us try to understand like how unlearning can be effectively done without retraining from scratch. So let's imagine that there is a user who has requested for the removal of some data point. So what will happen is, since I said that these data points are non-overlapping, so it may be either present in shard 1 or shard 2 or some shard k. So the same data point cannot exist in two or multiple shards. So which means, let us assume that it is present in this particular shard. So what the model developer will do, they will first identify the shard where a specific sensitive data point is present. They will delete the data point from this particular shard. Okay, let's say, as I said, 100 data points are there, you remove one, so now you have 99, and then you retrain this particular submodel. So what we try to also infer that only this model will be changed, but all other models will remain intact. So if we try to compare the retraining from scratch, what we try to do is, from the original data set, we delete one of the sample, and then we retrain the model from scratch. So only uh, we are going to retrain this sub model. So effectively it is good. So this is what I concluded. So unlearning a specific data point means that the submodel that is associated with that specific data point will be only retrained. So retraining can start basically from the last parameter that we have saved that does not include that data point. So if we look at the advantages of the CISA approach, the advantage in comparison to retraining from scratch, it is computationally less expensive, because what we have discussed is like we are training smaller models, and still we are able to maintain the accuracy which is close to the model which is retrained from scratch, because we are performing aggregation. And it's a flexible solution, because if we can think about evolving data, so what we need to do is like we have to form the shard, we have to form a submodel, and just plug the output of the submodel to the aggregated model. So this way it is good. But even though this approach is good, it offers certain limitation, and the limitation uh, is involved in the way the shard is constructed. So as I said, like the shards basically does not have overlapping data point. So if the shard is not having overlapping data point, then the problem is like the deep learning models or the machine learning models, basically they are not able to learn the interactions between the data points. So which means that if the first shard is containing data with indices 1 to 100, it cannot learn any interaction of the data points from 101 onward. So that is one problem. So which essentially means that they cannot be applied effectively to models like deep learning, which basically learns interactions between data points. So the complex interactions cannot be learned. And for this to work effectively, what we have to do is that in the training process, whenever there is a parameter change, we have to record the parameter changes, because when we want to negate the effect of the sensitive data point, what we have to do, we have to find out the last parameter updation and we have to negate it. So it requires additional storage because we need to keep the submodels and we need to store the parameter. So in an effect, the model's generalization capability might be degraded because the training is performed by various submodels and it is performed in an isolated way. So that is the basic problem. But if we look at the advantage, it is better in terms of a model that is trained from scratch. So after discussing about the exact unlearning, let us try to understand what is approximate unlearning. But before moving on to approximate unlearning, I would like to summarize few important points that exact unlearning is not effective for larger models like the open source large language models or closed source large language models, which has been trained with sensitive data points. Because if we want to remove any data point from a large language model, then we have to train from scratch, which is a computationally expensive task and it is not even good for the environment. So we have an alternative approach which is called as approximate unlearning, which basically works on the parameter space. So that means we try to look at the weights of the given model and then try to find out the activations or the gradients corresponding to the sensitive sample, and we try to negate it from the overall model. So one of the famous techniques which appeared in an artificial intelligence conference, which is like from a triple AI conference, an A star conference, is called as an amnesic unlearning. So what is amnesic? Amnesic is basically a state of a person where a subject or a person have a tendency to forget some information. So it's a medical condition. So the same idea has been transported into a machine unlearning approach where a machine unlearning model or machine a model will try to forget specific data points which is supposed to be critical. So amnesic unlearning, as I said, it is trying to delete or forget the influence of focused data point. And when I say focused data point, it's the data point corresponding to uh, a user and it is sensitive. So the best part of amnesic unlearning is that the model does not undergo a full retraining from scratch. Okay, it doesn't have to undergo the retraining from initial part. The only thing that we have to do is to negate the influence of the parameters that has been forced by the sensitive data point. So in summary, this approach is basically faster compared to the one that we looked previously. So let us try to understand how amnesic unlearning can be done. So during the training process, so basically there are two entities. One is the data owner, which means the user like us who are submitting the data, okay, like through mobile devices, through internet, in different forms rather. So the data owner, so there is a data owner basically, uh, they and there is a model developer, so somebody who is trying to develop a model. So there is, you can imagine that there is a user, then there is a company where there are multiple experts who are developing the machine learning model. So the model owner, what they have to do is they have to keep track of the batch where the sensitive data is present. I repeat, what the model owner or the machine learning model developer should keep record of, they should know the specific batch where a user sensitive data is included. So that is what we have written here, which example appeared in which batch. So when we know a batch, we also have an extra information that we know the parameters corresponding to every batch. So we have to save the parameters corresponding to every batch. And let us say a user like me wants to request for unlearning a specific data point. Then what the model owner will do, they will try to locate a batch where my data point is used, and they know the parameters corresponding to my batch, so they will try to negate the effect of my data. So in summary, what the model owner is trying to do, the model owner is trying to keep record of sensitive batches. And by definition, sensitive batches are those batches which contains sensitive data for training. So let us look how this training can happen. So the training is identical to the usual training process where you select a specific algorithm, let us say a deep neural network, any algorithm that you take, and you initialize the parameters randomly. The next step is we decide on the total number of iteration, which is epoch, and we take the complete training data set and we divide into some number of batches. So let's say the batch uh, consists of 256 sample, and let's say the total amount of samples in the training set is 6,000 60,000. So you divide 60,000 by let's say 256, you get total number of batch. Then uh, during training, what happens in every epoch, the batch of data flows through the model. Okay, so there is the calculation of activations, and eventually at the last layer, we calculate the loss. Okay, and if the loss is higher, we back propagate the loss, which means you perform the updations to the weights as well as the biases of every layer. So in this step, when we compute the parameter for every iteration and the batch under consideration, the parameter updates are always recorded. So in the classical training process, the parameter update of the final model, which is represented by theta, m is the model, it starts with the initial parameter, and then what you try to do is for every epoch, so here it is shown by e is equals to 1 to uppercase E, you select every batch and then you try to record the difference in the parameter. So here this delta is basically the change in the parameter, and that change in the parameter is added to uh, the parameters in the previous step. So this way what happens, the uh, final parameter of the model is calculated. But now when we want to unlearn, the first integral thing that we want to find out is sensitive batches. And by definition, sensitive batches are those batches which contains the sensitive data point corresponding to a user, and its effect has to be negated. So this amnesic unlearning inherently tries to find out the sensitive batch. So finally, what we would like to achieve is that we have an original model M which is trained with the sensitive data. We want to create a new model M dash which is called as an unlearned model without the effect of sensitive data. So which is like M, and this can be only created by removing the effect of the sensitive data from these batches. So how the update will look like? So we want to create a new model M dash which should have a parameter theta, and the training should start with the random parameters. Okay, and if you look in the previous one, so this part is basically our previous training process. Sorry, from here what we try to do is we would try to subtract the effect of all sensitive batch. Let us say we have two sensitive batches, so we will subtract the parameters that were saved in these two sensitive batches from the overall model parameters. So let us try to discuss about the performance of this amnesic unlearning, where this approach can be utilized and where it will fail. So amnesic unlearning will fare well if the number of data points that we want to delete are essentially low, and they are not, or they are basically present in fewer number of batches. Let's say we have 100 data points, and this 100 data points is present in one or two batch. So basically we want to subtract the parameters of only these two batches. On the contrary, if these 100 data points are separated in all batches, then the parameters corresponding to all batches have to be removed. So like this. So this part, subtraction part, will be aggressive, which means that the update will be too aggressive and it will bring down the utility of the model. So when so in summary, if the number of sensitive batches are low, the model efficiency is basically impact on the model efficiency is minimal. But if the sensitive batch is higher, basically it will uh, create problems in the utility of the model. So the final model that you have, it will not give good accuracy on the remaining data or the preservation data set. So the advantage of this technique is when we want to protect the privacy of individual record. Okay, so but there is a remedy if the data points are separated in multiple batches, or we have numerous amount of sensitive batch. What we have to do in order to have uh, the utility of the model preserved, or the fidelity of the model to be preserved, you can apply some sort of fine tuning. Okay, so the fine tuning is necessary to bring back the performance. Another drawback is, as you would have noted, that if we want to negate the influence of any data point, what we want essentially is to record the parameters of the sensitive batches. So that means the parameters have to be saved in the physical storage. So it requires large storage if the model is basically large. So, for another 5-10 minutes, I will quickly walk you through the Python demonstration of how amnesic unlearning can be performed. So, I prepared a small code from the available data set that is a part of Keras. So it's very easy to explain with MNIST. So we chose to use this example, and we know that MNIST is nothing but a digit classification data set consisting of 60,000 training examples and 10,000 test examples, and these are nothing but a collection of images, handwritten images. Every image is of size 28 cross 28, so 28 row and 28 columns. So this is just a snapshot where you can see that there are different digits from class 0 to class 9, so you have 10 digits. So through this example, I would walk you through how we can perform unlearning a specific class. Let's say I want to unlearn all images that are belonging to class 0, assuming that class 0 is sensitive. This is a scenario that I developed. So first what we try to do is we have the necessary import. So we have the scientific Python, which is NumPy, and since we are using TensorFlow, so we create an alias of TensorFlow, which is TF. So then we have the sequential model being imported from keras.model. Then since we are going to create multiple dense layers, so we use the layer tab as dense, and I will talk about flatten. And since I want to import a data set, so I will import data set from tensorflow.keras.datasets, and we want a specific data set to be imported called as MNIST. And then we have an optimizer, which is basically Adam. And then I use keras.utils in order to convert all these class labels like 0, 1, 2, 3 until 9 to a category, because it's a classification problem. So the first step that we try to do is to load the data set. So we will use mnist.load underscore data, which is like very common. And then we can collect the output in 4 different variables. So we have xtrain, which is the 60,000 images, and the corresponding class label in y underscore train, whose shape will be basically 60,000 comma. It's a linear array. Maybe you can imagine like this. Xtest, which is like 10,000 images, and its associated class label, which is recorded in ytest. After we load the data, the next step we do is to pre-process the data. So while we pre-process the data, what we try to do is we take every pixel and we try to divide the pixel with the largest pixel value, which is like 255. So how we do it, we say xtrain dot as type is flows 32. Okay, by default it is 64, divide by 255. So you are basically trying to normalize every pixel to have a value between 0 to 1, because the largest value is 255. So this we do for the training set, 60,000 images of the training set, and we also do it for 60,000 images of the test set. And finally, what we try to also do is we take every label, which is like 0, 1, 2, 3, and we convert it into category. That means we convert it into one hot encoding, And why we have used here 10? Because this is a 10 class problem starting from 0 to 9. So we one hot uh, uh, we encode basically the labels corresponding to the training set and the test set. Now imagine my sensitive data class that I'm taking is basically class 0. You can assume anything. For the demonstration, I'm just using here 0. Now we want to forget all images that have been used while training our deep learning model. So first what I try to do is I will try to find out the remainder data. That means this data will be consisting of all images excluding class 0. And how we try to do is first you take the labels. Okay. From the label, you try to find out the index corresponding to class 0. You try to find out the maximum because the size of every label is now 10. Okay. And if the index is not equals to 0, then those can be collected in X remainder. Likewise, you do white train. So that means you remove all labels which is not class 0 because I want to forget class 0. So now you have X train remainder and Y train remainder as the collection of sample which is the retain set without the presence of images corresponding to class 0. Now we create the topology of our network. So just a very simple network has been taken. It's a sequential model and the input is of size 28 cross 28. You have the first dense layer containing 128 neurons. The activation function associated with neuron is ReLU. Then we have the hidden layer which is having 64 neuron. The activation is ReLU. And since the output is a 10 class problem, we have 10 neurons and the activation is basically softmax. And once the model topology of the model is created, we compile the model by specifying the optimizer, by specifying the loss function and the metrics that is used, which is called as accuracy. So we will return the model to the caller function. So how do we train? What is the logic of training? So we write a function called as train with tracking, where you pass the object of the model, we pass the complete training set, its associated class label, then we specify the batch, then we specify the sensitive class, which is basically class 0, and the number of epochs. So first, we will try to compute the number of batches. So the number of batches is nothing but first finding out the total number of images in the training set divided by how many samples we want in batch. So let us say if the total number of samples in the training set is 60,000, we divide by the number of samples within each batch. Let us say it is 256. So 60,000 divided by 256 becomes the number of batches. We take two lists, which we will discuss later, which is sensitive batches, which will keep record of the sensitive batch. And the definition of sensitive batch is basically a batch consisting of sensitive data. And in our case, any batch which is utilizing images corresponding to class 0 becomes the sensitive batch. And this list all underscore parameters underscore update will keep track of the parameter updates while training. Now, how we can start with the training? We select the first iteration, we select the first batch, we will try to find out the start index and end index of the batch, and then from the training set, slice those number of elements, okay, so which becomes X batch, its class label, which becomes Y batch, and then what we try to do is we will investigate whether in this particular subset of data whether we have any image that is corresponding to class 0. So how do we do it? This can be done through line number 18 and 19, where we will iterate over y batch and we will check whether the label is corresponding to class 0. If any one of the image in this y batch is corresponding to class 0, then what we try to do is the index that we are selecting for that batch, let us say batch 1, for that particular iteration will be recorded in a list which is sensitive underscore batches. Then, as I said, we always have to keep record of the weights of the neural network. So we will say model.getWeights function. It will give you the current weight, and we train a batch of data on this model by supplying the batch as well as its corresponding class label. So train underscore on underscore batch is a function in Keras which will actually train batches of the data. So when we train a model, definitely the parameter changes. So what we do now is we will, in line number 28, we will try to compute the new weight, which is model dot get weight. So this is the old weight, this is the new weight. Now we will try to find out how much updates have been happened. So basically what we try to do is we subtract new minus old. So this is done through the list comprehension on line number 29. What we try to do is you take the new weights, you take the old weights, you perform one-to-one mapping, and basically you try to subtract them. So that which means that column number 1 of new weights will be subtracted with column number 1 of old weights, column number of 2 of new weights will be subtracted with column number of 2 of old weights, and so on, which is basically the parameter update. And this parameter update will be recorded in this particular list, which is all updates. So the all update list will store the iteration, batch, index, and the parameter update. And we can return the complete model parameter updates as well as the list of sensitive batches, which is stored in line number 19. And the definition of sensitive batch is a batch which consists of sensitive data points. So how the unlearning can be performed? So for unlearning, what we try to do is that we create a function called as amnesic unlearning. We pass here the object of the model. We pass the complete parameter updates and the list of sensitive batches. We get the current weight of the model, which is stored in a variable current weight. Then we will go to this list, which contains information like an epoch and a sensitive batch index. Then what we try to do is we go to the complete parameter of the model. We will check whether this epoch is equals to the current epoch here. If it matches, then we have to subtract the updates from this current weight, which is the final weight of the machine learning model. So how we do here, we write here a decision. If this epoch is equals to the epoch corresponding to the sensitive batch, and the batch that we are considering here, it matches with the sensitive batch index, then basically what we do is from the final model, you subtract the weights corresponding to this batch, okay, so which we can get from this, and then we will set the model weights as this current weight. So we have subtracted the weights corresponding to this batch index and make it final. So this function will return us the unlearned model. So let us do the performance evaluation. So for performance evaluation, what we try to do, we fix the batch size as 128 in this example, for epoch as 5. When we use the create underscore model function, we basically create a deep learning model with one hidden layer. Okay. And then to train, we pass the model, we pass the complete data set, we pass its associated class label, we pass here batch size, which is 128, we pass here the sensitive class, which is class 0, the number of epochs as 5. Now, if we try to evaluate the performance of the model, okay, original model, on the test set 60,000 samples, okay, we will find that the performance is like 0.9707 or 97% before unlearning. Now I will call the function amnesic unlearning, where I will pass the complete model, I will pass the parameters, and I will pass here sensitive underscore batches. So this variable sensitive underscore batch contains a number called as 0 because I want to forget all images of class 0. And this function will basically return a new model, which is model underscore u, which will comprise of the negation of the parameters corresponding to the updates caused by class 0. So after this is done, we will use this unlearned model. We will predict the performance of this unlearned model on the test set. So when I say test set, this test set can contain images of class 0, class 1, class 2 until class 9. And you can observe, as I told you previously, that amnesic unlearning is good if we want to forget one or two samples, and if we want to forget multiple samples, it does aggressive weight update, and that is why the performance of the model degraded to 0.10, which means the utility of the model is dropped, which was initially 97. So if we perform unlearning, the utility has come down, which is basically not good. How do we revive from this? So first, what I'm trying to do is I'm trying to store the indices of all images that are corresponding to class 0, which I will save in a variable called as xtest. And how do you do it? You go to the test set, and from the test set, perform argmax because it's a one hot vector. You find out the index, and if the index is corresponding to 0, store the indices of those images. Now I will perform model underscore u, which is the unlearned model, if I evaluate the performance on the sensitive data set. Over here, our model is performing really better. It has forgotten all the sensitive data because we can see the accuracy of the sensitive data is basically 0.08. But the problem exists over here. Even if we have forgotten the data point, the overall utility of the model has come down, which is not what is required. How do we get away with this problem? In order to get away with this problem, what we try to do is we take our unlearned model, we fine tune the unlearned model for some number of steps. So here we are fine tuning it for 5 steps with the remainder data. The remainder data is the collection of the samples where the elements of class 0 is not present. And once you do this, we see that the accuracy of the model has now again retained to 0.98. And now if you evaluate it with X test, it is expected that the performance, which was earlier observed to be zero point 0.1, should be improved. So it depends on how many epochs are required to bring in this performance. So I think with this I will stop because I have a lecture soon after this. So I think what we discussed today is basically the need of unlearning. What are the two major categories of unlearning, which is exact unlearning, where we try to remove the data points, and the second one is approximate, where we try to basically modify the parameter updates. So in exact, we looked at an algorithm called as CISA, which is sharding, isolation, slicing, and aggregation. And in case of approximate, we looked at amnesic unlearning, and I also showed you the code demo. So with this, I would like to close. If you are interested to know further, you can write to me, and I am ready to the questions now. Thank you.
So, anyone have any quick questions? We can direct to sir.